what is the physics? All of you know in SSC level you are studied some basic concepts related to the physics. So physics is a fundamental branch of science which is studies the universe and nature around us, and it is gives a set of principles based on the studying of nature and universe. That principles we can applicable technically, and those technically developed instruments, those are having the important role in our human beings' life. So physics is one prime core branch of the science which is interlinking with all branches of sciences, because if you can take any instrument, any electrical instrument, so that should be working with the principle of physics concepts. So nowadays you can't imagine without electricity our human beings' life. You know, the electricity is the invention of physics. So it is a prime role with the human beings' lives, right? You know, physics is having the different branches. We can study the overall physics in different branches. One branch is mechanics. You are familiar. You are studied your school level 10th class and 9th class. Motion of the bodies. Motion of the bodies deals with the mechanics. Particularly for the motion of the bodies can explain by the great scientist, that is Newton. By using the Newton 3 laws, so by using the 3 Newton laws we can describe the moving body or a motion of object. Motion of object. So therefore that is called Newton mechanics or Newtonian mechanics. What we are studied in the Newton mechanics? In the Newton mechanics, we are describing the motion of the body by the great laws given by the Newton. Newton first law, Newton second law, Newton third law. By using that 3 laws, we can explain the motion of a body under the external forces, right? So particularly before to explain those laws of motion, you have some basic terms related to the motion of a body. What are the terms we are using? First of all, regarding this mechanics, so in mechanics we deals with the motion of the objects, right? Particularly, we have to use some terminology in this studying of mechanics. The first one is we have to use to moving body linear motion. One term we have to use linear motion, or it is translatory motion. So actually an object can having the different types of motions, but very basic level fundamental motion, linear motion or translatory motion. What is the linear motion or translatory motion? For example, if the vehicle moving on the road is linear motion or translatory motion, means the body position is changes with time in one direction or two directions or three directions. Then that body is moving under linear motion or translatory motion. So we have most of the cases we are observing the bodies are in a linear motion or translatory motion. Means body position changes with the time in linearly in one dimensions or two dimensions or three dimensions. Such motion is linear motion. To define this linear motion or to study this linear motion, we have to use different terminology we have to use regarding the particularly when we are studying the motion of the body, linear motion of the body, we have to use different types of terms we have to use. Already you know. So again, just you recollect that terminology. So here, first one is rest. When we say an object is at rest, right? When we say object is in state of motion, the first point we have to give the condition for bodies. Right. So we have to discuss the differences between rest and state of motion. When we say object is at rest position, when we say object is in state of motion, next, when the body is in a state of motion, that motion of the body we have to describe by some terms. What are the terms we have to use there? One is displacement. So what are the terms we are using to describe the moving body or to describe the state of motion? Displacement we have to use, distance we have to use, and speed we have to use, or velocity we can use. Next, acceleration we have to use. So we have to use some physical quantities to describe the moving body. Okay, displacement, distance, velocity, acceleration. These are few quantities, and other are linear momentum, right? There are some other also there. So these are fundamental terms. I think you know what is the displacement of a moving body. How we can define the displacement of a moving body? What is the distance of what is the distance traveled by a moving body when it is going from one point to another point? Similarly, velocity, acceleration, linear momentum. Okay, so these are certain terms we are using to explain this linear motion or translatory motion, right? So first point, rest. When we say a body or object is at a rest position, how we can give the condition to that body is at rest position? So if you are observing the position of object with the time, if the position of object does not changes with the time, so then the body is at a state of rest position. If the body position changes with the time, for example, when the vehicle is moving on the road, suppose that initially it is at one point, at t is equal to 0, then it is started the state of motion. After some time, it is going to some other place. Then next after time, it is going to some other place. So the position of the object is changes with the time. Then that is in a state of motion. If its position is remains same position, does not changes, then that body is in a state of rest. Okay, clear? Rest means position does not changes. State of motion means position changes with time. So when position changes with time, then that body is under a state of motion. So that state of motion is linear state of motion or rotatory state of motion. That is the next case. But anyhow, that body position is changes, so it is in a state of motion. So when the body is in a state of motion, that motion of the body is, we have to define, we have to explain by terms, few terms we have to use it. Displacement, distance, velocity, acceleration, linear movement. So what is the displacement of a moving body? What is the displacement and distance? How to differentiate between the displacement and distance of a moving body? So for example, initially an object is at one point in the space. Suppose this is point A. Now from at this point in the space, the particle is at point A at the time t is equal to 0. Now from this point it begins to move in a particular path, like it is moving in a path. Suppose like this, it is going A to B, then it is going B to C, then it is finally coming to the point D in the space at the time t is equal to t seconds. So the particle initially at point A is started the state of motion in this particular path. It is moving in this rectangular path. So moving initially O to B. Suppose this distance is B, and then this side length is B, and then B to C length is suppose A. So in the time of t seconds, that body or particle is moving from A to B along this particular path. Okay. So now in this time interval, t is equal to 0 to t is equal to t seconds. T is equal to 0 to t is equal to t seconds. In this time interval, the particle or body is in a state of motion. So now in this time interval, the body is in a state of motion. So to describing the state of motion, so here it is going from A to D. To go from A to D, it is moving along one geometrical path. It is moving along an actual path. What is this path here? This is the actual path. It is moving along this actual path. So the length of the actual path traveled by the particle when it is going from one place to another place. So that is called distance. Distance of a moving body. When body is in a state of motion, it is moving from one point to another point or one place to another place. To go from one place to another place, it should be moving along a particular geometrical path. It can be moving along the particular geometrical path. So the actual length of the geometrical path traveled by the particle from initial position to final position is called distance. Generally, we are represented with d, small d. So here, what is the distance traveled here? This is the length b, this is the length a, again this is the length b. So therefore, while it is going from point A to point D, it is the total distance traveled is b plus d, 2b plus a. So the length of geometrical path, actual length of geometrical path, 2a plus 2b plus a. Okay, this is the distance calculation. Okay, so actual path length traveled by the particle when it is going from one point to another point. This is distance. I think you know, right? Now the next one, displacement. What is the displacement? So displacement we are represented with S. So displacement is the shortest distance between the initial point to final point. Initial point is A, final point is D. So initial to final shortest distance. You remember between the any two points, the shortest distance is always in a straight line direction. So therefore, now A to D, I draw an arrow. I draw an arrow here, A to D, because only in specific direction, only in straight line direction between the point A and point B, the shortest distance is possible. So only unique direction, therefore displacement is a vector quantity. Actually, what is a vector, what is a scalar, we have the chapter, but right now you remember displacement is the shortest distance between the initial and the final points of the moving body. That should be is always in a straight line direction. So now this is the displacement vector of the particle when it is moving from A to D. What is its magnitude? This is a displacement vector. I want magnitude, means length of the shortest distance. Magnitude is here, length of the shortest distance. So that is equal to A. Very good. Good. So whatever this length, this is the magnitude. So we can take this is magnitude of displacement is A. Why we are called this is magnitude? Because this displacement is direction, specific direction, unique direction, straight line direction, initial to final. So vector quantity magnitude, we are represented with a number, and the magnitude and direction we are represented with a vector quantity. So this is about the displacement of the particle. Okay. Next point is here. Next point is we want to define the speed of the moving body. Speed of the moving body we can represent it by V. Speed of the moving body is defined as it is the ratio of total distance traveled by total time taken. So this is the beginning time T1, this is the ending time T2. Beginning T1 is equal to 0, T2 is equal to T. What is the time of journey? Time of journey is delta T. Delta T is equal to T2 minus T1, that is equal to T. So this particle is in a state of motion for certain time interval. In this, how much time interval that is? T time interval, it is in state of motion. In this state of motion, in this time, it is traveling this much of distance. So speed is equal to total distance traveled by speed is equal to, we have to define total distance traveled by total time taken. So speed is equal to, we are represented as V, total distance traveled by total time taken. Now you tell me what is the speed you are getting for that example. Total time taken. This is the defining of speed of the moving body. Okay. Total distance traveled in by total time. What is the total time of this moving body? T seconds. In these T seconds, it is going to travel total distance is what? 2V plus A. So therefore, V is equal to, you are getting 2b plus a by t. What are the units here? This is numerator is the distance and denominator is time. So distance is length, length units are meter, time units are second. For example, this is 5 meters, this is 10 meters, and here the time taken is, let us suppose, time taken is 5 seconds. When the particle is moving from A to D along this path, it should be takes the total time of journey in 5 seconds. Suppose this length, this side length, this width is 5 meters and this length is 10 meters, then what is the speed of the moving particle? Now you can calculate the, for this values, B is equal to 5 meters, A is equal to 10 meters. What is the speed of the moving particle? Can you find? What is the speed you are getting for the value of width B is equal to 5 meters and value of length A is equal to 10 meters? For the total time of journey 5 seconds, what is the speed you are getting? Substitute the values. Suppose this width of this one is 5 meters. If this length is 10 meters, that is completing total time of journey is suppose 5 seconds. This is 0 and t2 is equal to 5 seconds. Then delta t is equal to 5 seconds. So 2b, 2 into b, here b is 5 meters plus 10 by t, t is equal to 5 seconds. So 5 2 is 10 plus 10, 20 by 5, 5 1 is 5 4 is, so 4 meters per second. If the width and length of that rectangular path is 5 meters and 10 meters, then speed of the particle is 4 meters per second. Right. Now you tell me the same question. What is the velocity? Velocity. What is the velocity? So next point is velocity of moving particle or moving body. Right? Velocity how to calculate? Velocity is equal to total travel displacement by total time taken. So velocity of a moving body is defined as total displacement traveled by total time taken. Total time taken. So this is also called rate of change of displacement. Displacement per unit time. Rate of change of displacement or ratio of total displacement traveled by total time taken. So what are you getting? Yes. So that is 10 by 5. You get 2 meters per second. But this is vector quantity. Specific direction, this direction only. So we have to represent with the direction. How we can represent the direction, that is we have to explain. But just what is the terminology we are using to study the moving body, just to explain. Okay, this is velocity. Similarly, acceleration. What is the acceleration? Suppose while the body is moving for a long time, suppose when it is at a point A, suppose at this moment, this body is having velocity, suppose v1 bar, and at the point D, suppose this body is having a velocity, suppose v2 bar. So during the motion of the body, at different instants, at different moments, the velocity of the moving body is different. Suppose when it is at A, this is having the velocity v1 bar. When it is at D, it is having the velocity v2 bar. You know how to calculate the velocity already. You know there is one moving body. While it is moving at point A, it is having certain velocity v1 bar. When it is at point D, it is having the velocity v2 bar. So therefore, whenever the moving body velocity changes with time, then it is in a accelerated motion. When the velocity of the moving body increases with time, then it is in a accelerated motion. If the velocity of the moving body decreases with time, then it is in a decelerated motion or retarded motion, right? So here it is having velocity at point A v1 bar, at point D it is having v2 bar velocity. So then velocity is changing. When the body velocity is changing with the time, that is in a accelerated motion. Okay. Therefore, acceleration of a moving body is defined as acceleration. Again, it is a vector quantity. This acceleration of a moving body is defined as change in velocity by total time taken. Total time taken. What is the change in velocity here? Final velocity at the D is it is having v2 bar velocity. At the initial moment t1 is equal to 0, it is having v1 bar velocity. Change in velocity per given time interval. In the delta t time interval, final velocity is v2 bar, initial velocity is v1 bar. So therefore we can take change in velocity v2 bar minus v1 bar by total time taken, delta t. Delta t is equal to what? T. So change in velocity by time taken, that is equal to t2 minus t1. So therefore here what we are getting here, v2 bar minus v1 bar by t2 minus t1 is equal to t. So this is acceleration. So simply you can write like this, delta v bar by delta t. What is the delta v bar? Total change in velocity. Yes. So delta v bar is change in velocity, final velocity minus initial velocity by time taken. So it is the ratio of change in velocity by time taken, or it is also called rate of change of velocity, because change in velocity per unit time. That is, we have to define rate of change of velocity. Okay. Can you tell me the units of acceleration? What are the units here? Velocity by time. Velocity units are meter per second by time. Therefore, units are meter per second square. So the units of acceleration is meter per second square. Okay. This is defining of acceleration. And similarly, retardation. When we say the body is under retardation, if the velocity of the moving body with time, if it is decreases, for example, at t is equal to 0, for example, it is having a 50 meter per second. It is moving in a straight line, such that suppose at t is equal to 10 seconds, it is having the velocity 5 meter per second. After 5 seconds, its velocity is coming to 5 meter per second. Initially, 50 meter per second is there. Means what? In this 5 seconds, its velocity is going on decreasing. So when velocity of moving body is decreasing with time, such type of motion, we have to say that deceleration motion or retardation motion. So whenever the data given about the moving body depend on the given information, with time whether velocity increasing or velocity decreasing, we have to identify. Then based on that identification, that body is in accelerated motion or that body is in decelerated motion, we can identify in the first point. Then after that, that acceleration is constant or changing, we have to identify. If it is acceleration is constant, so then that is called uniform accelerated motion. What is the difference between uniform accelerated motion and non-uniform accelerated motion? First of all, you know accelerated motion. When we say body is in accelerated motion, when the body velocity increasing with the time, then such motion is we are called accelerated motion. Right. Now this accelerated motion we have to define as two terms. One is uniform accelerated motion. Uniform accelerated motion. Uniform accelerated motion and non-uniform accelerated motion. I am talking about accelerated motion only. In the accelerated motion, velocity of the moving body with time increases. So with time, the velocity of the moving body is increasing. But how it is increasing? In which manner it is increasing? Based on the method, in which way that velocity is increasing? Based on that, uniform accelerated motion, non-uniform accelerated motion. Okay, non-uniform accelerated motion. What is a non-uniform accelerated motion and uniform accelerated motion? Here, example, you tell me what is the condition. I am given the example, you tell me the condition. For example, in the case of uniform accelerated motion, there is a particle started from point O. It is started with initial 0 velocity. So U is equal to 0 initial velocity and T is equal to 0. T is equal to 0. It is started with rest. Simply from rest. Now it is going to the point B in T is equal to 1 second. Year to year it is travels 5 meters. Then it is going from B to C. So then at T is equal to 2 seconds. Here it is, or you can take here, for example, here 0 and here it is 5 meters per second. Here velocity here 5 meters per second. When it is coming to here the velocity is 10 meters per second. When it is coming to the point D, the time is T is equal to 3 seconds. So when it is the velocity is here 15 meters per second. So if you consider the motion of the particle A to B or B to C, C to D. In the A to B, here initial velocity is 0, final velocity is 5 meters per second. So when it is going A to B, in the time of 1 second, what is the acceleration here? What is the acceleration here? Acceleration is delta V by delta T. Delta V means final minus initial. Final is 5, initial is 0. 5 by 1, so 5 meters per second square. So here, when you take B to C, in the B to C journey, final velocity is 10 meter. Here initial velocity is 5 meter. 10 minus 5, 5. Time interval is what? T2 minus T1, 2 minus 1, 1. So 10 minus 5, 5 by 1. So again here A is equal to 5 meter per second square. Again here C2D also you get 5 meter per second square. If the body changes its velocity, changes its velocity, equal velocity in equal interval of time. In first 1 second change in velocity 5 meters per second. In next second the change in velocity 5 meters per second. In next 1 second the change in velocity is 5 meters per second. If the moving body changes its velocity, equal velocity changing in equal interval of time, then that body moving with constant acceleration. When body moving with constant acceleration, here acceleration 5 meters per second square, here acceleration 5 meters per second square, here acceleration 5 meters per second square, then that motion is called uniform accelerated motion. If it is not, for example, here it is started with initial velocity 0, it is going from A to B in the time of t is equal to 1 second, but here velocity is 5 meters per second. Next, it is going B to C. When it is coming to the C, the time is 2 seconds, but here velocity is suppose 12 meters per second. When it is coming to the point C, its velocity is 12 meters per second. Similarly, from C, it is going to the D, where the time is equal to 3 seconds. Suppose here its velocity is 20 meters per second. Now, A to B, time of journey 1 second. Time of journey 1 second. Change in velocity what? Change in velocity Vb minus Va, 5 minus 0. Here change in velocity 5 meters per second. B to C, time interval is 1 second, but change in velocity 12 minus 5, 7 meters per second. Here C to D, change in time interval is 1 second, but change in velocity is 20 minus 12, 8 meters per second. So, what we are observed that in equal interval of time, while the body is moving, when the body is moving, if in equal interval of time, first interval of time, first 1 second, change in velocity is 5 meters per second. But next 1 second time interval, change in velocity is 7 meters per second. And next 1 second time interval, change in velocity is 8 meters per second. So time intervals change, but change in velocity is different. So if the body moving such a way that in equal interval of time, the change in velocity of the moving body is unequal, such motion is called non-uniform accelerated motion. Okay, we have actually equations and detailed discussion about the motion in a straight line, but right now just only I am giving the terminology of this one, just brief introduction about the terminology. So what is the meaning here? Their accelerations are different. Here A1 acceleration. What is acceleration here? 5 meters. So accelerations are different. So acceleration is not constant. So here acceleration is constant. So when a body moving with constant acceleration, such motion we have to define uniform accelerated motion. For that uniform accelerated motion, we have to give the equations, kinematic equations to study the uniformly accelerated motion in a linear motion, 1 dimension or 2 dimension or 3 dimension. We can apply the equations, kinematic equations. Acceleration is negative. For example, we are moving in the suppose in the car. Initially, that car is moving with, let us suppose 80 meters per second, 80 kilometers per hour, or you can convert it into meter per second. while it is moving with 80 km per hour, in oppositely some vehicle is coming. So the driver is making the brakes, applying the brakes, then gradually velocity of the car is decreases. So when velocity of the car is decreases, in that case, the acceleration is negative. Final velocity is less than the initial velocity. So that is called negative acceleration. That is we call the retardation. That is we call the deceleration. Okay. So these are cases we are getting in different situations. We are getting retardation or negative acceleration when force is acting against the moving body. So while the car is moving in forward direction, when the driver applying the brakes on the car in opposite direction, force acting, retarding force acting, so that its velocity going to gradually decrease. So that should be negative acceleration or retardation. Okay, I hope clear. So when we are having the negative acceleration, when the retardation force is acting in against the direction of motion, that velocity gradually decreasing. Such case we get the negative acceleration, right? So this is about acceleration, uniform acceleration, non-uniform acceleration, right? And the next one, we have the different types of state of motion. You know, this is translatory motion. When the body moving in a straight line manner in one dimension or two dimension, that is translatory motion. And similarly, you have the other motions. What are that? Oscillatory motion. So different types of motions we have to discuss in detail while you are coming that concept. So what are the different type of motions you are observing that? One is you are familiar, right? So what are the different kinds of motion of the bodies we are observing here? The first one is translatory or linear. That is you are familiar, linear or translatory motion, right? Linear or translatory motion. What are the other types you are observing? What are the other types you are observing? Different types of motions in our surrounding. Linear and translatory motion is one. Yes. Oscillatory motion. Oscillatory motion. Special case only. Special case. Oscillatory motion. Special case is simple harmonic motion. We have one complete chapter. Simple harmonic motion. You have one complete chapter in our first year syllabus. Simple harmonic motion. Discussing about the simple harmonic motion is you have one complete chapter. So that is said to be oscillatory motion. This is a simple harmonic motion is one special case of oscillatory motion. It is having some specific conditions. Based on the concept of simple harmonic motion, you have one chapter in our first year syllabus. Okay, what is the oscillatory motion? In oscillatory motion, that body is making two-angular motion about a fixed point. So here, this is one fixed point. About this fixed point, the body is going to make two-angular motion from this mean position, equilibrium position. The body is moving. It is now from mean position going to away up to some extreme point. That point up to maximum which point it is moving. That point is called extreme point. So that distance, maximum distance between the mean position to that extreme point is called amplitude. Then its direction is changing. Again now it is moving towards the mean position. But when it is coming to the mean position, so actually here it is having the initial velocity v. When it is going to the extreme position where velocity at point A is extreme point of velocity is 0, then direction is changing towards the mean position because by this the force acting, so therefore direction changing, then it is moving towards the mean position. So when it is coming to the mean position, again velocity becomes maximum, v velocity is getting, because of this v velocity, because of the direction of velocity, because of direction of inertia, then it is moving further in this direction to the left extreme position v, where it is changing the direction. So then it is moving towards again mean position. So this is started at t is equal to 0, then going to the right extreme position, then change the direction, then coming. So when it is coming to here, the time taken is 1/4 of the total time to complete this oscillation. This is one oscillation actually. We are dividing into 4 parts. This is first 1/4, this is second 1/4, this is third 1/4, this is fourth 1/4. So to make one oscillation, the particle about mean position, from first mean position, it is going to the right extreme position in the time of 1/4. Total time taken to complete one oscillation is called time period. So initially t is equal to 0 at above, then it is going to extreme position A, then changing direction, coming to the mean position, then going towards the left extreme position, then changing the direction, then it is coming to the mean position. The total time taken to make this oscillation is called time period. So here this complete oscillation we are dividing into 4 parts. This is first 1/4 of the oscillation. Time taken is t/4. When it is at point A, the time instant time is equal to 1/4 of the total time. When coming to the point O, but direction of motion is this direction. At this moment, time is equal to, this is t/4 time, this is t/4 time. So when it is here and direction of motion this direction, time is equal to t/2. Similarly, when it is here at the B and the direction, time is 3t/4. And again, when coming to here, total time t is taken. So here, it should be making oscillations about the fixed point, or it should be moving a to and fro path about a fixed point. So such motion is called oscillatory motion. So oscillatory motion is a periodic motion. One of the characteristics of oscillatory motion is periodic motion. You know what is a periodic? It is repeating the same path. It is repeating the same path at equal interval of time. For example, if t is equal to 0, it is at point 1. Now, next at what time? Then t is equal to t, it is coming to the same position. After completing one oscillation, it is coming to the t. Next, again, it is moving along the same path, then coming to the same point when time is equal to 2t. So, it is repeating the same path in equal interval of time. So therefore, oscillatory motion is a periodic motion. So we can explain, we can discuss about this periodic motion, in particularly in chapter simple harmonic motion. We have the detailed discussion about the various properties of this simple harmonic motion. Okay, this is one type of motion, is oscillatory motion, right? What is the other type you have? What is you have the other type? Any other type of motions are there? Only these two? Any other kind of motion? Tell me what is other kind of motion? Yes. So the next one is what we are called exactly rotatory motion. Rotatory motion. So circular motion is part of rotatory motion. So another category of the motion of the body is rotatory motion. So circular motion is also a part of rotatory motion. When body is in rotatory motion about the axis, every point on the body is in a circular motion. Okay, right. So circular motion come under rotatory motion, right? So in this rotatory motion, you are observing in our universe. We can observe this rotatory motion in different cases. For example, in our universe, in our planetary system, around the sun, planets are revolving in a rotatory motion in a different elliptical path. And around the different planets, their satellites are revolving. Okay, so that is a rotatory motion, right? So because of that rotatory motion and because of the gravitational force between the sun and earth and between the earth and the moon, gravitational force is active. When they are coming in the same straight line, that is what we are solar eclipse and lunar eclipse. During that moment, gravitational force is maximum, so therefore energy is more. So in that cases, you are getting the more energy. Okay, so that is related to the gravitation or gravitational effect. We have to study in gravitation chapter. Okay, so this is about the in rotatory motion. We have to define again two types of terms. While the body is in rotatory motion, you have the two types: rotational motion and revolution. Rotation and revolution. Regarding the rotatory motion, what is the rotation and what is the revolution? What is the difference between the rotation and revolution? What is the rotation and revolution? For example, this is for example, this is our Earth, right? Earth is rotating around the sun. You can take this is small size. Somewhere here, sun in the universe, in the space. About this sun, this is moving in a elliptical path like this. Okay. While this Earth is revolving around the sun, it should be rotating about its own axis. The Earth is rotating about its own axis. This is spin motion. Spin motion of the Earth. It is simultaneously Earth is rotating about its own axis, and as well as this Earth is rotating around the sun in an elliptical path. You know, time taken to complete one rotation of Earth about its own axis is, what is the time period? 24 hours. So in the spin motion, spin rotational motion, the Earth is rotating about its own axis, that is passing through the center of Earth. So it should be rotating, so that to make one complete rotation, we should be making up 24 hours. So rotational motion means the body rotating about its own axis. That is rotational motion. So here, Earth rotational motion. So to make one rotation, to complete one rotation, the time is 24 hours. So that is rotational motion. Body rotating about its own axis is called rotational motion. Whereas body revolving around a sun in an elliptical path. So that is called revolution. The time taken to complete one closure path around the sun, that is called revolution. So rotation of the Earth and the revolution of the Earth. So I think you know the difference. What is the time period of the rotation? Time period of rotation of Earth is 24 hours, and the revolution of time period of Earth is to make one complete closed path to making up a complete closed path around the sun. It should be take the time how much? 365 days. Okay, right. Okay. So here this is about the rotational motion of your body and revolutionary motion of your body around the other body. Body rotating about the other body is called revolutionary motion. Body rotating about its own axis is called rotational motion, right? Okay, right. Next, this is about the rotational motion, and we discuss one complete chapter, rotational mechanics. This portion is most weightage portion regarding the IIT advanced level and the IIT mains level, rotational mechanics, studying about the rotating body, various concepts related to the rotating body in the rotational mechanics. Most weightage part in IIT exam streamline, rotational motion, rotational mechanics, right? And next one, the other part of physics is heat and thermodynamics. So first part is mechanics. So in mechanics we deals with the linear motion, rotatory motion, and SHM, and we take into the gravitation effect also. When we are taking into the gravitation effect, we can including the gravitation, right? So the next other branch of physics is heat and thermodynamics. Another part is heat and thermodynamics. In heat and thermodynamics, what we have studied is this branch. In this branch of physics, we have to deal with the heat energy. So we deal with the heat energy. What is the heat energy? Heat energy is the energy possessing by the gas molecules of a gas due to their random motion. When you consider some amount of gas in a cylinder, or when you consider some amount of gas in a container, those molecules in that container, they are moving in a random motion zigzagly. Every molecule having certain mass and every molecule is moving with certain velocity, so that every molecule is possessing kinetic energy. Every molecule is possessing kinetic energy. Total gas is possessing some energy. So that is internal energy. So we have to calculate the internal energy of a given gas system. And thermodynamics mainly it should be deals with the conversion of heat energy into the mechanical energy. Mechanical energy is conversion into the heat energy. So this is based on the conservation of energy principle. So heat energy we should converting into useful work done. Similarly, sometimes the work done, mechanical work done, is converting into the heat energy. So that should be deals with the heat and thermodynamics. So in this heat and thermodynamics, particularly, what are the terms you have to familiar? One is measurement of heat. Heat is the internal energy of the substance or internal energy of the gas system. So this heat energy we can measure by the instrument what we are called heat. The heat energy we can measure by the instrument. What is that instrument we are called? Calorimeter. So we have one concept and one chapter in this heat and thermodynamics, calorimeter. It is an instrument. This instrument is used to measure the heat energy of the given system or given gas. What is the heat energy? Heat energy is the internal energy of the gas. That should be depend on the temperature, right? And other one, temperature measurement. This is calorimeter measures the measurement of heat. It is used to measurement of heat. Measurement of heat. And there are to measure the temperature, we have to use the Instruments, what are the instruments we are using? Thermometers. So thermometers we have to use to measure the measurement of temperature. What is the temperature of the object? Temperature of the object is measures the coldness or hotness of object relatively. Relative to the other object, it should be measures the relative coldness or hotness. Okay, so that relative coldness or hotness of a given object is measured by the thermometer. That should be defines the temperature. So by using thermometer, we can measure the temperature of the object or temperature of the body. So we have to use different scales. What are the different scales we are using? We are using the different scales of temperature. One is Kelvin scale and one is centigrade scale and one is Fahrenheit scale. So degree centigrade, so degree Fahrenheit and Kelvin scale. So in the Kelvin scale, we are using the fixed points, lower fixed point 273 Kelvin to 373 Kelvin. This is upper fixed point. This is lower fixed point, Kelvin scale. In degree centigrade scale, lower fixed point is 0 degree centigrade. This is a boiling point of melting point of ice, and upper fixed point is boiling point of water. This is 100 degree centigrade. In between, this scale is dividing into 100 divisions. One division indicates 1 degree centigrade. So when it is kept on the hot body, the mercury in this scale is raised to some point. So up to what length it is raised, so that degree division indicates the measurement of temperature. So this is centigrade scale. Similarly, Fahrenheit scale. In Fahrenheit scale, you have the fixed points here. Lower fixed point is 36 degree Fahrenheit, and here 32 degree Fahrenheit, and upper fixed point is 212 degree Fahrenheit. Here the number of divisions in this scale is 180 divisions. Here number of divisions are 180 divisions. Here 100 divisions. In centigrade scale 100 divisions, 1 division 1 degree centigrade. In Fahrenheit scale 1 division 1 degree Fahrenheit. Similarly in Kelvin scale also 100 divisions. So 100 divisions. 1 division is indicates 1 degree 1 Kelvin. Okay. So by using the thermometers we can measure them. So by using the these scales, we can measure the temperature of the body. So we have one particular concept regarding the measurement of temperature, that is the thermometry. By the thermometry, we can discuss detailed working of these scales and principle of working of the scales and their related calculations, like thermometers and the other factors in heat and thermodynamics. So this is deals with the energy. So therefore, what we have kinetic energy, potential energy, heat energy. So these are the different forms of energies. Kinetic energy and potential energy are mechanical energy. That should having the conservation. It should be converting into one form to another form. Okay. And the heat energy also, most of them is converting to some other form, but some fraction is dissipated. So therefore, heat energy may not conserve. These are two terms related to the heat and thermodynamics. And the other main, the core branch of physics is electricity. That should be called electromagnetism. So electromagnetism is a branch of physics In this electromagnetism branch, we study the properties of the charged particle or the phenomena executed by charged particles when they are at rest position, when they are in the state of motion. So the electromagnetism is the branch of physics. It should be studied in two different categories. One is it is studies about the charges. This branch of physics is studies about the charges. So it is divided into two categories. In category 1, we studied about the charges at rest. So charges at rest, you know what are the charges existing in the atoms and molecules of the material. So you know electrons are negative charged particles, protons are positive charged particles. When you have the charges at rest position, studying of charges at rest position, that branch of electromagnetism is called electrostatics. Electrostatics. So in electrostatics, we deal with the charged bodies at rest position, charged particles at rest position, and we study about the various phenomena, various concepts related to the charges at rest. Right? Similarly, in the second category, charges in state of motion. Charges in state of motion. Again, we consider the state of motion of the body characteristics, state of motion concept. Using the state of motion concept, when charged particles are in state of motion, what are the phenomena producing by these moving charged particles? That should be studied under charge in a state of motion. That is called electrodynamics. Electrodynamics. Why? Because it is called dynamics. Charges are in state of motion. Okay. So in electrodynamics, you have to study the different concepts. What are that? Current electricity. So that means electricity. Current electricity we have to discuss, and electromagnetic induction, AC currents, alternating currents, and electromagnetic induction, and moving charges and magnetism. So this is one important branch of the physics. It should having the most important role with the human beings' technical connections. So therefore, this is the most weightage concept for IIT mains level and advanced level, electromagnetism. So we studied in two categories, electrostatics and electrodynamics. Okay, and then after we have one more branch, optics. In that optics, we deals with the light. So different concepts related to the light we have to discuss. Already you know the fundamental phenomena, reflection, diffraction, interference, right? So those points we have to regarding the complete light related phenomena in optics. That is one branch of physics, and another one branch is nuclear physics. Optics is one branch, and another one branch is nuclear physics. This is actually belongs to the modern physics. Okay, in nuclear physics we deals with the nucleus, inside the nucleus of the atom. So what are the phenomena executed by the nucleons of the nucleus? Those things we are discussing in nuclear physics. Okay, in that nuclear physics we have some concepts: nuclear fission, radioactivity, law of radioactivity. Those things we discuss in nuclear physics. Okay, overall in complete physics we have to discuss different branches, various concepts related to the physics branches. Mechanics one, next one is heat and thermodynamics one, electromagnetism, optics. This is nuclear physics in modern physics. Okay, I think all of you is following my whatever I'm telling, I think. Okay. So actually this is only what we have in 2 years portion and what we have to learning in this 2 years portion. Just I'm giving the things. I'm not discussing any syllabus. Okay, sir. Okay. So next week onwards, I think we have started the actual syllabus, right? Thank you, one and all.